What's up, everyone? Welcome back. And well, if you are new here, then welcome and not back. So, in this video, we are going to do linear regression all in one video. As I said in the last video, if you have not seen it yet, you can. But the thing is that the 5 videos that I have made till now, it will be a complete summation of that. It will be kind of a summary of that. So, I want to do linear regression all in one video as quick as possible. So, let's get right into it. And yeah, if you want something really in depth, then you can just go back, watch the 5 videos. They are really long. I mean really long, about 1 hour long. So you can just go back and see that. So you can be you can have your hands really dirty with linear regression. And yes, we'll be following along with a lot of linear regression as well. So without wasting any of your time, let's get straight into it.
Everybody ask me how I know. I smiled at them and said she told me so. Everybody ask me how I know. I smiled at them and said she told me so. Everybody ask me how I know. I smiled at them and said she told me so.
Okay, so we are here on my computer screen, and if you are not following along, if you are new here, then you will be like, okay, great, I want to learn linear regression, but what the hell is this? Where are you really writing your code? Where's the sublime text? Where's the PyCharm, right? You can write your code there, no issues. I am on Google Collaboratory. Well, there are really less videos about Google, so let me just explain a little about that. So you can just come in here and you can search for Google Collab. So after searching for Google Collab, you should be here and you can just say show collab, and this is a Google Collab, and you need to just click on new Python 3 notebook. Yes, there is an option for Python 2 as well. I don't want you to do that. I want you to have Python 3 because we are going to use Python 3, and as well as Python 2 support has been suspended, so no more Python 2, right? So you'll be here, and I have renamed it as linear regression dot, and that is for this is a notebook. So this is a collaboration between Jupyter as well as Google. Awesome. Okay, so what do we need? Well, we need a data. And which data are we going to use? We are going to use the running data. I have made a video and I have uploaded a video about us running, and that is how we collected it. So there was a timestamp, actually there was a distance of 15 meters, and we ran through it. Like, it was me and two of my friends, so we ran through it, and that is how we collected the data, that like how much time we took. So the thing is that I programmed a game using Pygame, and by mistake I imported the humans. So what happens is, the humans gets inside the game once the game is started. Now once the game is started, we were inside and there were ghosts behind us, and we had to run for 1.5 kilometers, and the person who finished the race before the ghosts will be winning. So we want to see who will win. Okay, so that is the data, and that is of, well, not obviously complete 1.5 kilometers. We run half of that, so that is about 250 kilometers. Sorry, not 250 kilometers, it is 250 meters. So we ran for 250 meters, and that is the data for every 15 meters that we ran. So using that data, we will be predicting the models, and we will be training linear regression models so that we can train and predict what will be the time taken by the person who will be running after that. Now I will be predicting it for one person, and it is your homework to go and check for the other 2 persons and tell me in the comments down below that who wins, as well as link your Google Collab page to me so that I can just come there and see what you have done. And the reason why I want you to come on an online site like this, like the Google Collaboratory, is because of the fact that here on Google Collab, it is really awesome, and you can just do everything. You need not install things on your local system. So if you have a system that runs slow, then you can just do things, as well as when we'll be going ahead with something really awesome, something like self-driving cars. So in that case, we will need an online support. So that's it. Okay, so we are here, we are right in front, and let's just get into it. Now what do we need? Well, we need the data. So where's the data? Well, I have my data stored here. So this is my data, and that is running data on CSV. You can go to my website, that is thecodinghumans.com, and we'll see it right from there. Okay, so how am I going to import the data? Well, you can just come in here, and inside this we need a data, right? So what I can do is, I can just I can do something like that and drag and drop it inside. So that's it, and it will give you a little warning that says that it will be automatically deleted once you have refreshed the page. So just keep that in mind. Okay, now we need the data. How are we going to take it? Well, we need something that it has, that is called as panda, and we're going to take it as PD because, well, we are really lazy. So we imported the pandas. Okay, and now after importing the pandas, what are we going to do? Well, what does pandas do? First of all, pandas is a library that can help you to import stuff really easily. So we are going to have a variable that I'm going to call as data, and I'll have something that pd dot read underscore csv, and inside this you need to pass your data. Now what is the name of the data? It is running data csv. I guess it is running data csv, running data, what the hell am I doing, csv dot csv. So that is the name of the file that I have. Let me just check it. Yes, it is running underscore data underscore csv dot csv. So it is here, it is running data csv, and I can just mention in here that it is separated using semicolons, so using commas. So if I am able to open it, well, let me just see it real quick, whether can I open it. Yeah, so here's the data. Okay, so here's the data of us running. Okay, so these are the top 10 rows that it has. Actually there will be 50 data, as you know. So this is the data, and it is of Om Shri, Aryan, and Shubham. So Shubham is my name, if you don't already know that. So it's Om Shri, one of my friends, Aryan, again another friend, and that's Shubham, it's me. So this is the data of us running, and that has from 1 to number 50, and it should ideally increase or be something like that, so that using that we can just do some kinds of stuff. So if you open this in something like Sublime Text, you will be able to see that it is separated using commas. So that is why I am mentioning comma. That is something that I'll leave up to you. Now what I'll do is I'll just run this, and I have my data. Well, now if I say give me my data dot head, now what data dot head does is it gives me the top 5 things. Okay, so after running this, it gives me the top 5 things. So this is our top 5 result that we got from the data. Similarly, if you have data dot head, you can also have data dot tail, and that will give you last 5 results. Okay, now this will come in really handy when we will be doing some stuffs. Okay, this done. Well, just tell me if I am too fast, because this is a video to be fast, because I have been really slow in the previous 5 videos. If you want something much in depth, you can just go there, refer that. You'll be amazed by the depth that we go. And yes, there are more videos to come, so don't worry. Okay, so we are here with data.head and data.tail. Now we have imported our pandas and we have imported that. What do we need next? Well, first of all, let's just see how our data looks like. How? There is something that we have in Python called as matplotlib, and I'm sure if you're here you have already heard about matplotlib, and yes, most people have it like that, but I'll just type it for you. .pyplot as plt. So I have that. So I imported matplotlib.pyplot as plt. Now with matplotlib all set, after importing matplotlib, what I'm doing is I'm calling out a class of matplotlib. Like matplotlib is a library inside which there is one class called as pyplot. So I'm calling out that class, and I'm naming that as plt, like we did it here, because you know I'm really lazy. So with this plt, what I can do is plt dot, let's say I want to see what is the running data of Om Shri. Okay, so what I can say is, first of all I can say Om Shri, and what do we need? Well, first of all we need an x and a y. Now in our case we'll be plotting it so that in our y-axis, that's this, right? So in our y-axis what we'll have is, it is the number of time that we took, and in our x-axis we will have all of the it will have the number of runs. So for that, first of all we will need our x, right? So what is our x? Well, it is a list, okay, and it is a for a in range, and let's say 50. So it will have 50 elements, and if you just want to see what it is, so I can just print out x for you, and yeah, so you can just see it as a list of total 50 elements from 0 to 49, and then since we have a total of 50 data sets, so that's what we'll be doing. Okay, now that's it. What we need is plt dot plot dot, well, the plt dot scatter, plt dot scatter. Now if I have plt dot scatter with me, wait, plt dot scatter, let's just spell it catter, yeah. So we have plt dot scatter. Now what do we need to pass in? We need to pass in the x and a y. Now what is an x? It is an x. And what is a y? Well, that is data, oops, my fault, that is data. And inside of our data, what we have is, inside the data we have something called as Om Shri. So after that, if I say plt dot plot and run that, it should show me this graph. Now what is this graph? This is a graph of Om Shri trying to run, and as you can see it's 0, 10, 20, 30, 40 until 50, and this is the number of time that it took. So the maximum was 27 seconds and the minimum was kind of something like 7.5 seconds. So let's just come and confirm it here. Yeah, so the minimum was 7.2 seconds. Maximum is not shown here, but that's what it is. Okay. So now that you know how we can plot the data using matplotlib as well, what do we need? We need to predict. But before predicting, let's just break it into x and a y. Now how will we break it into x and a y? For now I'll just call it x, and let's say the y, since our x values you already know is right here. What is our x? It is this, right? So let's just make this, let's just make a comment. I'm really sorry, I have been programming a lot in JavaScript, so I have a habit to do that. Let's just name a comment that is the x value of my data. So that is my x value of my data, and now we need a y value, right? Now what is a y value? Well, it will be data, the same way we wrote it there. It will be Om Shri, right? So it is Om Shri. So inside the data we have our Om Shri, so now we have an x and a y ready. Why do we need an x and a y? Well, it is really important because to predict you need an x value and a y value. Well, if you want to see what really are we doing, what the hell are we really doing here, it's really interesting. I will really suggest you to go there and check it out, or you can just go to my website and check. Like there will be some models that I want to show you. Well, if you can just wait for a second, let me just grab out something for you. I have something. Alright, so I'm back. Well, I was just taking this. So this is a data. So this is something that I've programmed in JavaScript. So what we can do is I can just plot some points. Well, probably that was a really bad example. You just put it again. So let's say this is one data point and this is another data point. So the line will fit. And this is what really linear regression is all about. So you will have many points out here. Okay, and there should be a line that will fit this point. So for all of the points that I have pointed here, this is a line that fills all of the points. Okay, now coming back here, there should be a line, something like this, that will fill all of it, right? So how are we going to really predict that line? That is really important. Okay, so for that thing, what we need is, we need to first of all predict, right? So our y will be data Om Shri. Okay, amazing. Now what do we need? Well, we need something so that we can train the data. For that we need we need something that sklearn has to offer. Now what is sklearn? Let's just come in here and see. sklearn. So scikit-learn, as you can just see here. So let's just open. Yeah, so you can do many things in here. For now we are on regression, right? And in regression we are specifically at linear regression. So this is a linear model. Okay, now yes, we will be going into everything. Don't worry, if you are following along with this channel, that's why just keep subscribed. So if you're following along with this, you can see we'll be on linear regression. Linear model, linear regression. Yeah, so we're in here. Okay, now inside this what we need is specifically linear regression, right? Now if I can come here, sklearn linear regression. So this is a platform. Okay, now this is what we exactly need, right? So sklearn.linear model.linear regression. Now that actually, so the linear regression is in itself is something that there is a lot to do calculation. You need to if I am just giving you an example right from here, what you need to do is you need to have some data plots, right? And then the data needs to fit it. So let's say if I have one point here and one point here, how does the line know where it needs to go? If I have one point here and one point here, so how does the line know where it needs to go, right? So that is what we need to predict out here. That requires a lot of math, and since this is a linear regression all-in-one video, I don't want to make it go for 3 hours because that won't be one video. So I want to keep it at least within half an hour so that you can just have your good grasp over that. So we are back here, and what we need is something that sklearn has to offer, right? So let's just come in here and import sklearn. Now that we have sklearn, what do we need? Well, nothing, right? So if you remember, we were here and inside sklearn there was another class called as linear model. We need that, right? So we can say, well, first of all, there are two things, okay? Since we have this data, and so that we can make sure that this is the data that the machine is predicting, and so like it's kind of like this: you have a lot of data with you and you want to give some of the data to the machine to predict it. But in your case, something that can happen is machines are really good at storing data, right? And that was the reason why machines were made at the that is the reason why machines were made at the first point. So that we can just really understand that machine is not remembering what we said it to do, and it is really predicting the things we need to predict, and we need to have something for the test. For example, if I was a machine, yes, I'm a computer. Just imagine that, okay? If I'm a computer and if you tell me, okay, so I will be teaching you something, and let's say you are my teacher, okay? So you are my teacher and I'm a computer. What happens is you teach me, let's say, alphabets, okay, or you teach me some words, and you want to test me on some sentences. So if you test me on how I can frame the sentences, and if you teach me some sentences, like let's say the coding humans is a sentence, okay? The coding humans is a channel where I can learn linear regression. So that is a sentence, and with that sentence, with your hand, if you first of all test me with that, if you first of all train me with that, or if you first of all make me learn using that, what happens is later on you don't have any idea if the same question is given to me in the test. Now in linear regression that is not the case. I'll tell you why. But we need to separate out our data inside a training and a testing set, okay? So that is really important. How are we going to do that? Well, there is something again in sklearn, because this is really common in any sort of machine learning thing that you do, be it linear regression, logistic regression, k-means, knn, anything, any freaking thing that you have. Probably not the last two that I said. Yeah, most importantly, neural networks. So inside those, what you need to do is you need to have a training and a separate data. You need to have a separate data for training as well as testing. So we need our X train and we need our X test. Then we need our Y train and our Y test. And what will that be equal to? Well, that will simply be equal to sklearn dot model selection dot train test split. Now what does this long thing do? Okay, it is sklearn dot model selection dot train test split. Now inside this you need to give three things, okay? Your X, your Y, okay, as well as what should be your test size. So in our case, let's say the test size is something like, how much should I give? Let's say my test size is kind of like 0.1, so that will be 10% of the data, okay? 0.1, so that will be 10%. In our case that will be 5, okay? So after running this, let's just see whether it runs. No, it's giving me an error. sklearn has nothing as model selection. I think it is there. sklearn model selection. Yeah, model selection or train test split. It is right there. sklearn model selection. Did I made a typo out there? Let's just sklearn and model selection or train test split. Probably not. And attribute error. Field is attribute as model selection. It is really strange. How dare I have it? Let's shuffle. Just put test size, train size, random state shuffle. Let's go model selection, report made this fit. So there's some error, I don't know why. So let's just try something. Import sklearn dot from sklearn import model selection, and here is model selection. Okay, yeah, it did work. I don't know, there was some error when I was just trying to put it directly. So what I did was I did from sklearn import model selection, and then I did model selection dot train test fit. And now what I have, if I just come here to my next one, and if I want to print, let's say okay, and what do I need to print is, let's say X train. Okay, so if I just want to predict X train, so this will be this should contain all of the 45 numbers, right? So it will be some random 45 number that it has. So to see on what model will it be predicting, let's just have a plt dot scatter. What do I need to scatter in there? Well, I need my X train as well as my Y train. Okay, so with that said, if I say plt.plot and run that, it will simply give me this data. And so this is a random data editor, and based on this data it will predict it. Okay, fine, awesome, lovely, fantastic. Now what do we need? Okay, well, we need to create the model. How are we going to create the model? It's pretty simple. Okay, let's say I name it as model, and a model will be sklearn dot linear model, linear underscore model. Now I'm not an expert, so the thing is, what I do, I always keep the reference open. But the thing is, when you will be there and you'll program it for multiple number of times, you will remember this. So it is sklearn.linear model dot linear regression. Okay, so dot sklearn.linear model dot linear reg. I guess that is a spelling. Linear regression, yeah, reg, REGRESSION. Okay, now let's just try running that and hope there is no error. Okay, so I don't know, there is some error in the collaborative, probably it is still in the beta mode. So what I can do is from sklearn import, what I want to import, linear model. Okay, so I imported linear model from here, and now if I try to run the linear model, okay, so now it did work perfectly. Now I have my model ready, but it doesn't still know of what the hell it needs to do. Okay, now what do we need? Well, if I say that if I have my linear data and I need to predict it, okay, and first of all, for prediction I need to give it some data. Okay, I want to give it some data using which it can predict. How? For that I need to train it. How am I going to train it? I want to train it, I want to fit it. What? I need model dot now fit. Now what this will do is, it's not fit, it's fit. Now inside fit you need to give your x and a y. Now if you have given your x and a y, and how do I know that? Well, inside this, if you come to predict, score, fit, is fit, score, predict, get param, fit. Okay, so it is self, x and a y, and then the sample weight, that is none. So in our case we gave it the x and a y, and now it should fit the data. So try running this, and whoa, amazing, we ran into an amazing error. Now why is this error amazing? Because it was expecting a 2D array and we gave it a 1D array. How can we fix it? It's pretty simple. What I can do is, well, first of all, there are two ways to do that. Okay, I'll tell you both the ways. So where's our x and a y? You need to first of all find that. Okay, so our x is here. What I can do is I can enclose this inside another. So this should do. Now it is a 2D array. What is a 2D array? It is an array inside an array. So our x became a 2D array. Now what about y? Well, y should be a 2D array as well. So what I'll do is I'll just put a 2D array here. Now let's see whether it works. Let's see whether it works. And if it doesn't, I'll tell you some other way, because well, it should. It ideally should. But the thing is, if it doesn't, I'll tell you something else amazing. Now what is this error? Then sample 1 and size inside array, adjust any other informant, value error, and samples equals 1, test size 0.1, test. Oh wait, first of all, I'm really sorry. Okay, I just forgot to do one thing. Inside this, we are passing in this. We are passing in an x and a y, and with n samples for test sizes trained, the resulting set will be empty. Addition the resulting set will be empty. Okay, so it's actually, let's just do one thing. Instead of passing in an x and a y like that, let me tell you the best way to do that. And actually you can just see it was actually predicted, and it was set out here. So it is array.reshape. Now if you don't already know about NumPy, that is a thing that is only available, yes, only available on NumPy, something .reshape. So if I want to reshape something in here, what I can do is, let me just run this and see. Okay, so now that's fine. What I need is, I need to reshape. So it like the error itself was an amazing error, because it said it was array.reshape. So it is array.reshape -1 to 1. How? And first of all, I made a mistake. It is not x and a y, it is x train and your y train, for the same reason that I said you. Okay, so for that, before I give it this, what do I need? I need to say x train equals to x train dot reshape, x train dot reshape -1 to a 1, as well as my y train equals y train dot reshape -1 to a 1. Now let's run this, and yes, I will run into an error, because x train that is my mistake. Okay, attribute error, list has no attribute reshape. Okay, so Shubham, you said that it will work. Yes, I did, and I promise that it will. Okay, how? For that, you need to do something really simple. What you need to do is, after this, you need to import NumPy as np. So it already said what I need to do is as np. Now I have my NumPy. Why do I want a NumPy? Well, because if I convert everything to a number array, everything becomes so much easier. NP array and just encloses inside this. That's it. That's it. What I need to do. Nothing much. Okay. So if I just convert everything to a numpy array, np.array, and now let's just try running that. So make sure you run the things after making any changes. So let's run this as well, and now it even ran perfectly with that. And if I come in here, and now try to do that, ND array has no tree shaper. DSHAPE. I hope you don't really make as many mistakes as I do. Okay, so done. Now we have a ready. Now what we have ready is our model. Now we have trained a model and it is ready to predict stuffs. But before predicting some stuff, before doing some crazy stuffs with it, I want to see how it really looks like. For that, what we need is, well, we need a line. How can we have a line? Well, let's me just get to an online whiteboard. I can just teach you right there. Okay, so I'm on a whiteboard. I don't know how long this video is going to be, but I hope it's not too long. Hang on, yeah. Okay, hope it'll work. Okay, so I'm here. Amazing. So what do I need? Well, let me just come in here, select a marker, and we need a line. Okay, now if you know a little bit of maths, let's say I have this as my y-axis and this is my x-axis. Okay, I'm very bad at drawing. I'm just using, I don't have any pen, so I'm just drawing everything with my hands. So this is my y-axis and this is my x-axis, and inside this, let's say I have a line that is kind of like that. Now how can you define, oh wait, let me just do one thing. Can I just make line with some other color? It will look much better. Okay, so let me just make a green line, kind of like that. Now how can you define a line? Well, in mathematics you can have any point on this line. Let's say this point, that is a point on this line, that is, let's say right here. So if I have this point somewhere, it has a x value and it has a y value. Well, there's an equation that is one of the most famous equation of mathematics, and that is y is equal to mx plus c. What is mx plus c? Well, m stands for the slope. What is slope? Well, if I have this line and this is its y-axis, or rather the parallel to x-axis, then this theta, it is the tan theta. So it is tan of this theta. So tan theta is equal to m, or this is the slope of the line. So what is the difference between this line and let's say this line? This is much less steep than this, so it has a less theta than that one. So that is it. Okay, so if you you don't need a complex if you don't want to get into mathematics, don't worry, it is pretty simple. Just remember y is equal to mx plus c. What is x? X is every value. It is exactly this value that we have here. And what is c? C is the intercept. What is the intercept? Is a distance from this point to this point. So it is this distance right there. If I have that distance and if I have the slope, then I can just make a line using my x and a y, because y I can predict, and what is x? Well, x in our case is a number, right? So let's just make a line real quick. How can I make a line? Well, I have my x values with me. What I need is my y values, right? So if I need my y values, so let's say I can just say y of the line. Now what will be the y of my line be? If I need to predict what my y of the line will be, what I need is, for every value of x do I need to calculate the value of my y, right? And that is how will I be calculating what it is. So it's pretty simple. How am I going to do that? It's pretty simple, okay? Let's just focus right in here. I have my y line, and what do I need? I need to make a line. So I have my x values, and for every x I need a y. So what I can say is I need mx plus c. But how am I going to get mx plus c? M. Now if I just come in here, this is for the transient split. Let me just close this. This is for linear regression. Okay, so after this we have something that is coefficient and intercept. Now this coefficient is this intercept that we need. So how can we access it? It is, well, for our reference, let me just make a comment saying y equals m times x plus c. Okay, so what do we need? M. It is model dot coef and underscore. Okay, so it is model dot coef underscore into x. What is our x? Well, our x is our x. And what will be plus c? What is the c? It is model dot intercept underscore. So this will give me y values of every x. Okay, and now if I want a line, what I can say is plt dot plot, or rather first of all let me just make the points scatter. Let me just make the points, so that will be x and a y that I have. And if I want to make a line, it will be plt dot plot. No, it won't be plt dot plot. Plt dot scatter. Plt dot line. Plt dot scatter. Plt dot scatter will scatter the points, and plt dot plot. I'm not wrong. That is how it's done. Wait a second. I can't be wrong in here. Yeah, it's plt dot plot. I can't be wrong in here. Okay, so it's plt dot plot. Was it working later on? Okay, plt dot plot. What do I need to plot? Well, I need my x and a y, and in our case the y will be y line. And with that, what do I need to say is plt dot show. So after running this, hopefully it says x and y must be of same first dimension but has 50 and 150. It is for my plt dot plot. Okay, so it's for x and a y. Fine. Y model dot coefficient into x. What if I say, well, for that probably I need the first one for that and the first one of this. So let's see whether it works now. Yeah, it does work. So it was actually an array. So I just took the first one element. It will be an array of just one element. If you want some proof, so what I can do is print let's say what is it, slope. And what is the slope? It is nothing but model dot coef, and then we need a intercept. What will be our intercept? It is nothing but model dot intercept. Okay, so let's just run that again, and yeah, you can just see it's an array. Intercept is actually a 1D array. It is a 2D array. That's amazing, it worked. But see, the thing that it plotted is really amazing. It is this thing right in here, and you have this beautiful line. Now for our case, let me just change the color of this line so that it can look a little nicer. that's not required. You may not. So I don't think you can see it. Yeah, so this is much better. So I have my blue points and I have my red line, and you can just see this line perfectly, almost perfectly fits this line. So without any doubt, this should be a best fitting line, and that is what linear regression is all about. Now, what if I want to predict a value at some particular stage? Let's say a particular x value, I need my y value. Well, I can use a line, right? And that is a function inside my, well, sklearn. So I can say prediction, and how am I going to really predict it? Well, it's really simple. It is one of the most simplest things that you can do in here. It is prediction equals model dot predict, and inside this you need to give it an x value. Now it has to be a 2D array, and let's say I want to predict the value of 46th run, let's say. So if I want the value of 46th run, I can just run prediction, and later on I can print predict, and I can just print prediction. So it says it is 11.950 seconds. Let's check what is in our 45th term. So it is it was our data dot tail. So I specifically took that because of the fact that I know it will be in our tail. So 46th term, right? So 46th term is 11.36, 11.95. Amazing accuracy, isn't it? On 46th term it says 11.36. He actually took 11.36 seconds, and it was predicted as 11.95 seconds. So you can just see the amazing accuracy of a model. But here's the crux. One thing I want you to say is, if you go and watch the video of somebody else, well, the almost the exact content will be taught that they teach, okay? But one thing that most of the videos do wrong is they have accuracy as model dot score, and inside this they pass in their x test. Now if you remember, we had our x test and our xy as well, right? So our x test and an y test. Okay, now since we have this as well, if I run this, first of all it should throw me an error. Sorry, I was not talking about that error. TST. Okay, yeah, so this is the exact error that we are quite familiar with, right? So you already know how to handle it. It is x test equals x test. Okay, so I don't know from when the video actually stopped. I'm sorry for that. So x test minus 1 comma 1, and sorry, it is y test equals y test dot, oh my goodness, dot reshape. What do I need is minus 1 to 1, right? So minus 1 to a 1, and now let's just run this, and hopefully it will. NDI is not callable. Why? Oh, reshape. Yeah, now if I come in here and print my accuracy, it is in minus. Now why is this stupid? Okay, first of all, if you know some maths, and by just knowing about it, probability can't be negative. It has to be between 0 and 1, right? Moreover, this is not probability. This is not at all probability or the accuracy of a model. Accuracy has to be between 0 and 1, and this is not. Then what is it? Come here, I'll tell you what is it. It is r squared. What is r squared? I'll tell you, don't worry. So predict, and this is what we did. and now comes the score, right? So we were here on score. So what is score? It returns the coefficient of determination, the r squared of the prediction. What is r squared if you're asking me? Well, let me just tell you. If this was our model, okay? If this was our model, and what do we need? Well, I guess I can just teach you right here. If this is one point and this is the line that I have, it is a distance between this point and this line. So that is r squared. So between this point and this, that is called as r squared. So if that is my line and that is a point, so it is a distance between and the square of the distance and the summation of all. That is r squared. And linear regression is everything about minimizing it. Okay, so for now this is not at all accuracy. What is it? It is none of our context, and if you want to predict anything, you just predict it using this. Nothing much. Well, if you are like, okay, good, awesome, fantastic that you just did that, but what if I want to calculate the total runtime that OMSHRI actually took? How am I going to do that? Well, it's very easy, right? Now here comes the Python. Now there's no more machine learning involved. You can just do simply by using some Python. What do you need? Well, you need the total runtime. So let's have the total predictions, right? So predictions, I can say predictions is a list, and inside the list I can say, what is it? Well, inside the list, what do I need is all of the predicted values. So I need model dot predict. What do I need to predict? Well, I need to predict A for, I need to predict A for A in range. For A in range, well, now it will be 100, right? Let's just run that, see if it works. It should, ideally it should. Okay. Predictions. Let's try. See what it is. Yeah. So it is all of the prediction according to the model of what it is. Okay. So it starts here, and this is all of the prediction till 100. Now, if I have all of the predictions perfectly set, I need to calculate the total runtime, because if you see inside my prediction, it says that for the first time he will take 11 seconds, 11.28, 29, 31, 32, 33, and it's still till 100. So I have a total of 100 things right in here. So what I can do is I need to calculate the sum of all. So I can say Ohm run time sum. Probably I can come up with a better one, but that's it. Ohm runtime sum. Now what we need is for prediction, or rather for P in predictions. For P in predictions, okay. For P in predictions, what do I need is Ohm runtime plus equals, what do I need to add everything? What do I need to add every time? Well, that is P. And what is a P? If you just saw here, a P was a collection of array, actually 2D arrays, right? So inside I need to unpack kind of like that. So this should work. And after that has run, I can just say print the total Ohm run time. Okay, so let's just see how much time he takes. So it is 1200 something seconds. So let's just see how many seconds to minutes. Okay, so that is 20 minutes, almost 20 minutes. So he took exactly 20 minutes to run the race, or rather the model predicts that he will be taking 20 minutes to run 1.5 kilometers. Now I want you to do the same for Shubham and Aryan. Calculate and figure out who takes the minimum amount of time, and then that person will win. So I hope you enjoyed this. Go to the link, go to the codingimage.com, enjoy there, and yeah, this thing will be there as well. So you can just play with the animation. It's quite interesting to play with it. You can just download the data, do whatever you want to do with it, explore the data, do whatever. Just keep innovating, and bye bye for now. Hope you enjoyed the video. Bye.